Okay, now let's determine what are the signals or what are the boolean expressions for these four signals, right? So let's select the uh, A flip-flops is signal first. Okay, so we are going to build a K map for this. So we have three inputs here, right? I, QA and QB. I will just use I, A and B for the simplicity here, but you need to consider QA and QB, right? So I, A, B. So there are three variables, so I will be using a three variable K map. I could be 0 or 1. AB could be 0 0 0 1 1 1 1 0, right? As you can see, it is wrapping around because we need to change only one bit at a single adjacent position in this K map. Okay, so now I'm going to copy the circuit or the values from here to this one. Then I will determine this is the signal for uh, SA, right? So this is the S signal for the A uh, A flip flop. Okay, so I'll copy from here. If you are not comfortable with the order, so you can write the order here 0 to 7, right? But yeah, let's follow this one. uh, this is 0, right? Because we followed the order in the exhaustive list here, it does not matter, you can follow the order. This is going to be 0 1, this one don't care, uh, 3 is going to be 0, right? Then here is the fourth position is 1, fifth position is going to be 1, sixth position is here is 0, seventh position is 0, right? So now what are the groups available? As you can see, we have one don't care signal, so it can be included or excluded, does not matter, but we have to find the maximum groups, right? But here this does not belong to any type of group actually, so we can just consider these two and these two, and that will be all, because we don't need to essentially include this, other than it is making a big group for us. But now it is not the case, so we will just use these two. And what is the signal now? Let's say will be I is 1, right? So I, and what is common for these two is A bar, right? A is 0 in both positions, so you can use I A bar. I will use dash here, dot, not dot, right? Plus, because we have another group to add, right? So what is the other group now? I does not matter for this group, right? For this group, what is the configuration? A bar, right? A bar and B. A bar or A dash dot B, right? Here also the dot is there, but okay. So this is simple. Then let's continue to the next one as well. So it's the same way. Now we completed this one. Then R, right? So I A B 0 1 0 0 0 1 1 1 1 0. Okay, so I'm going to copy the, sorry, this one going to be R A, right? R signal of the A flip flop. So this is 0 0 is don't care, 1 is 0, 2 is here, right? 2 is 0, this is going to be 1 3, 4 is 0, 5 is 0, 6 is 1, 7 is 1. Okay, so now what are the groups? Again, it's essentially similar, but yeah, we don't need to include this one. You can go with this group and this group, right? Because this one actually does not contribute to any of the bigger groups. If there was X here, then then it would be quite easy, right? You can bundle everything together as a single for group, but here is the one, so it is no use for us. So what is the equation now? Boolean expression. Here this one is AB, right? A and B plus, what is this group? I and A, right? B does not matter, plus I A. Okay, so let's move on to the next one. I A B again. So 0 1 0 0 0 1 1 1 1 0. Okay, so now I'm going to derive S of B, right? S of B. So it's going to be 1 0. Here second position is 1, third position is 0, fourth position 0, fifth position don't care, sixth position 0, seventh position don't care. Okay, so what are the groups? This one we can just ignore actually. There's a single group here, right? Because this is wrapping around, you can use the single group available here. Okay, so what is the configuration now? It is I bar, right? I dash. Then what are the common feature here? A is changing, B bar is not changing, right? B is always 0, so I will be using B bar. Okay, there is single group here and it is easy. Okay, so last one is let's go IAB 0 1 0 0 0 1 1 1 1 0. So let's copy this row here. 0 1 0 1. Fourth position is don't care, fifth position 0, sixth position don't care, this is going to be 0 as well, right? So this is also easy, single group. We can group it like this. So what is the output? We are considering R of B here, right? So R of B, right? So it's going to be I bar, because this is 0 always, right? I bar, then what is common here? B is common, right? A is changing, B is common, so it will be B. Okay, this is dot or end. So now we have entire set of signals, and if we give this signal to two SR flip-flops, we have the entire circuit which is necessary to run this state transition circuit. Okay, so yeah, what else is asked in the question? So we have now it is being asked that we derive the equation for R input of the QA flip-flop, but now we have derived all four inputs, and there are different three different loops where circuit could be operating at any given time, right? So yeah, let's see how to do that now.